Oké. Daar is de implementation of the Jacobi polynomials of degree n, degree 0 being a constant. Let's draw them. I'm just going to concentrate on let's begin with 0, 0, which are the Legendre polynomials, which are the special case of the Jacobi polynomials. And we're going to draw them over the interval that they are orthogonal. Orthogonal. How the hell do we pronounce it? Ja, dat wordt een Jacobi polynomial. Yes, a Jacobi polynomial. Let's call this t. So when I use t, I mean something in the interval -1 to 1. Then x is going to be a transform of that. And let's start with n equals 1. That's just a straight line. And then alpha and beta. Sorry, I want to start with this one. Beta also equal to 0. So yeah, again, then you, when the Jacobi polynomials are a family of polynomials which depend on alpha and beta. And if you set alpha and beta both to 0, then they are equal to the Legendre polynomials. And that would then be a function of t. To give it the return type, I think. Oh yeah, definitely, because this function doesn't even return at all. So it's defined in M-real. Should work. MP-real, I mean. Yeah, I already removed that. So I removed the compute Chebyshev zeros. Now let's just I'm just going to comment everything out for now. Yippee, so that's a straight line. Yeah. I am on. Now we could definitely find these things, I think. So if everything is correct, then also the Legendre polynomials must be defined over between -1 and 1, of course. Then being a special case of the Jacobi polynomials. So we go to the web, we look for Legendre polynomials. Wikipedia has it, and there's my picture. So yeah, between -1 and 1, and P1 is P0 is just 1 everywhere, and P1 is a line that is equal to x, so that runs from -1 to +1 as well, which is what we had, right? So -1 to 1 and -1 to 1. And all the others are also in that same range, so that's a good thing. Let's just draw exactly this picture. So I'm going to run n from 0 to 5, but then manually specify the y range. Otherwise, I would have to do P1 first anyway. And otherwise, it would get the wrong y range. just add it. And then let's add a y range as well, from -1 to 1. You have to grab an. Actually, I would like to have different colors. I could have. Oops, main. To define a color pool. Supposed to find extrema, so better look at there. How that uses the color pool? No, it's like that. That just gives an index. Yeah. What the heck? I'll just define a little array here of the colors. Diagonal color. Here, this one is well, what kind of color is this? I don't know. Blue. Yeah, aqua. Yeah, this one, cyan. I was just gonna say it. I think it's like well, a bit darker than dark cyan. I got it. Who cares? Undo, redo. Where am I now? It was not the last thing I changed. It did something with color. What the fuck? Oh, it is defined in... what I would say... No, okay. Anyway, usually I do this, so missing parentheses still. Should be a draw line cell. Really? That must have been namespace then. Yeah. Was it is a namespace? No. So confusing. Oh, it's without using. Sorry, that was the trick. Just an alias. Yep, that's how we do it. Make an alias for the namespace. Okay, we just use color here. Now, is that correct? Yep. I press Alt to switch window, but no, immediately terminates. Okay, let's compare to that. It's not correct, is it? It ain't correct. The green one is at the top. Maybe I should set line width to something way better, so I can actually see what where it is. Yeah, I see that this is green. This is cyan, I mean. So that is that one, and then we have this line, and then then it's completely wrong. This one starts at 0.2. That's not a Legendre polynomial. But yeah, it was only ChatGPT that told me that alpha and beta equal to 0 are the Legendre polynomials. Or did I get that from no. Right now, I'm thinking that ChatGPT was just full of shit. So I don't see any mention of it. Well, it would be a special case, but yeah, that's what they say here. Gegenbauer polynomials. What is that? That's weird that they just don't say what then alpha is for the genre. I mean, it must be alpha is a half, but they don't even say it. That's weird. Yeah, really weird. Picture, picture, picture. Of course, this doesn't give pictures. Damn it, man. This is way more complicated. If you ask me, then what? Oh, here it says, if alpha and beta equals 0, then it reduces to the Legendre polynomials. Which are that? Therefore, the definition that I got from ChatGPT is just wrong, because it does not draw these polynomials, it draws something else. No, this one was correct, but that one was already wrong. So we can check this one more. P1 should be this. That is alpha plus 1 plus not this. Alpha plus 1 plus alpha plus beta plus 2 times t minus 1, so it's, maybe I should rename t to z, that seems to be more well, that's what I use here. Here they use x, so yeah, whatever. Divided by 2. No, that's the same. Ah, fucking hell. Very irritating. Or is it the same? Find my Legendre again. The orange, oh, it is green, sorry, green, yeah, but no, not the same. Still some scaling factor wrong. Why is that? Or where's my scaling factor? I don't know, it's Legendre, Jacobian here. This is what it says. So, so for alpha and beta equals 0, and then you have the Legendre stuff. It's just 1 plus, and then the 2 drops away against that. Oh, wait a minute. That is P1. Yeah, that's a straight line. That is a straight line. So this becomes 2, drops away against that 2. This becomes 1, drops away against minus 1. So yeah, okay. It is correct. So then my, or at least the recursive well, ChatGPT came up with this, and it's just wrong apparently. Maybe recurrence. Okay, so use this. It's just literally written out what we need here. So A, let's define this A here. A is n plus alpha. B is n plus beta. So then Pn equals that divided by this. So let's begin with this. So something times n minus, so Pn minus n. Minus, I guess, something times Pn minus 2. So A4 is apparently equal to this. 2 times A minus 1 times B minus 1 times C. But then afterwards you have to divide by this. Yeah. So apparently A3 that we divide by here equals this. 2n times c minus n times c minus 2. So A3 is 2 times n times c minus n no, sorry. Yeah, actually. This is wrong. We know it is wrong, so I don't have to look at it. Let's just redefine the whole thing. So we have 2 times n times something, where the something is this, or c minus n times c minus 2. And then A4 becomes, where is it? A4 here is the enumerator of Pn minus 2 to the without a minus sign, so that should be this part. 2 times a minus 1 times b minus 1 times c. Because then this A4 is correct. And then we have the A1 and the A2. The A2 is the constant part that is not multiplied with t. So that is going to be C1 times this, here's the t, the z. So C1 times this, C minus 1 times A minus B times C minus 2n. Okay, and then the part that is multiplied with z is c minus 1 times c minus 2. That will be this part. Yeah. Must be correct. Let's try this then. Nope. Well, this one is correct. This one is still at the top, this one is still like that, but those were constants. And the ones that we changed, then we have the next one is this one, which indeed should start in this corner, end in that corner, and touch half here, 0 or half. according to that would be the green one. So touch is a half here. But then the next one, the red one, should start in -1, -1. It doesn't. It's too low here. What did I do wrong? Some bloody picture. I did not make a mistake. Now I am thinking that maybe the Wikipedia page is wrong. Because how else? Okay, I see the problem. I'll keep my comments, but that should be inside the loop. Duh. No, that looks good. Yes. Now it seems also reasonable to assume that it works for bed S1. Statistically, although I would have, I really would like to see an external graph. Maybe you can ask Wolfram to plot it. I have no idea how to do that though. So just ask JTV again. Okay, so now we switch to the Jacobi polynomials with beta equals 1. And then I'll try to compare the result with what Wolfram says, and if it still fits, then yeah, we have a working function. Yeah. I'm not convinced. It is true though that all of them end in 1 1. So that's definitely one thing then. But we're gonna need a larger y scale, it seems, for certain things. Or are they just going to plus or minus infinity? It seems likely actually. No, just a straight line is not going to minus infinity. Let's try a larger. Just try 3, I guess. Okay. So this one is 1, and then we get minus 2, plus 3, minus 4, plus 5, and minus 6. So if I see that back plus a shape more or less the same, and it ends all in 1 1, then we're definitely having the same function. Now here's our constant 1. So that's definitely fitting. Yep, and this one does end in 1 1, and it starts at minus 2. Right. Okay, how do I include the y range to use? Comma y from. Pay up. Okay, I won't zoom in. Let's make this a 2. Now that looks 3 to me. And 1 here. So yeah, that's the green one here. starting at 3 and then going down, more or less having a minimum at 0.2 and then do 1, 1. 0.2 is there, totally happy. And the next one then starts at -4 and goes like up, up, down, up. Yep. Now I'm already convinced, but let's test the other ones as well. To make it a 1 in a billion that it is actually wrong, even though it looks right. So that should be starting at 5. Yep, looks like my graph. And that one starts at -6. Yep. Perfect. Okay, so we have an implementation then. A working implementation. Let's keep it. I'm going to commit this, I think. Now I'm going to make it more interesting, because we're just going to work with complete polynomials instead of evaluating them. So the Jacobi thingy here, this takes a real immediately and returns a real, but we can also just ask it to return a polynomial, which you can also do iteratively. Sorry, recursively. I think I can close this window here. Yeah, so I can look at the chat again. Yeah, I need a name. Let me just give it a name. Jacobi P symbolic. Normally I use absolutely never ever abbreviations, but this is a test of a test of a test. So at some point it is too time consuming to think long about variable names. I wanted to return a polynomial and I'm going to use my own library because I don't think we need much accuracy here. A double is good enough. So I'll just use a polynomial, which I think is in math. And then we don't have a t, of course. Yeah, to return empty polynomial. I think, yeah, let's include a header here. So math polynomial is an arbitrary polynomial, or arbitrary degree. Just stores all the coefficients in a vector. No, we don't have a default constructor apparently. No, yeah, you have to pass the number of coefficients. I guess the maximum number of coefficients. Could of course set coefficients to 0. No, n. Because in the end this is going to return an n-dimensional, sorry, an n-degree polynomial with a name. The name borrowed from Mr. Jacobi. Now I wanted to compile. Oh, I'm sitting in debugging stuff, so we have to pass a name as well. This thing requires a name, comma, debug only. Was it? CW debug only. No. A Jacobi P generated thing. Now it must compile. Good. So now I want to do the same thing as above, but then symbolic, which means that I'm going to define yeah, let's just define these two. Not sure, maybe not the one. I mean, I could. This is just a constant, 1. I'm not. Let's try not to do that. 1 here. So I'm going to say this is a polynomial, P1. And it is it has a degree n. Everything must have degree n, I think, even though this is degree 1. Or am I wrong? No, I might as well give it a degree 1, and I have no evidence that that is not workable. Yeah, you can only pass that, and then afterwards we have to set the coefficients, I think by assigning. Yeah, this one. I can get a reference to a coefficient, and so just assign all the coefficients afterwards. So this is degree 1, and now we have to assign it, which means that P1 0 is the constant factor. And the constant factor is of course equal to this formula, but then with t equals 0. Okay, let's see if we can simplify this. This is times 0 minus z is minus 1. And so we can remove that and then put a minus here. All divided by 2, which means that I might as well write 0.5 times alpha 0.5 times beta and 1 instead of dividing it by 2. And then let's distribute the minus. So this is a minus, and this is a minus, and this is a minus. And then subtract this, so we get plus a half times alpha. Minus a half times beta, and then the plus 1 and the minus 1 drop away against each other. So that is a half times alpha minus beta. Lots of work. And then this one must be the part that is not const, but that is linear with t, so the coefficient of t. Now that's constant here, so I remove that. And the minus 1 here is also constant. So I can remove that part. And then the t itself is just itself, so I can remove that as well. So then we get, well, multiply all of this with a half again, instead of dividing it by 2, which is then a half times alpha plus beta plus a half times 2, which is 1. And then that's the coefficient of t to the power 1. Okay. No. Next step. Special cases. Well, could have done this one first. In the end, I just need to copy everything. Let's just copy everything. So I don't have to scroll up and down. So we're going to return an n degree n polynomial. And if n equals 0, then that must be a constant. But we just return the result here. I still have to define it though. So result constant. Constant is in 0 is 1. And then we calculate P1, and if n equals 1, then we just return P1. And that works because if n equals 1, then this thing has the same, well, it's dynamic. The type is, thank God, the same, so I can do it even if n is not 1. It's going to try to compile this anyway. But it works because if we get here, then the degree of the size of the array of coefficients is going to be equal to 1. Initialize the two previous. Okay, so we want to have a PNM2. Yeah, I'm not sure I want to do that at all, actually. Maybe just if I have to define this, this one anyway, I might as well define it up here and then return that, if you get what I mean. Okay. Normally I call a result always result, but in this case it's going to end up being, well, if you use this abbreviation, it's going to be PN. Ignoring the Jacobi name and ignoring the alpha and the beta, yeah, maybe I should just make it in a little n. Although we have an iteration here, I don't know. It's a bit vague. I would call it maybe like that. That seems more logical. Yeah, I think that I like this. So that is the result, and then we start with initializing it like P1. Because let's yeah, so if I make this variable, these two variables, so they are being reused and the degree gets higher and higher. But not as high as not higher than n minus 2 for this one, and not higher than n minus 1 for that one. So theoretically, maybe I could also say I want to do the minus, yeah, the minus 2 is logical to do first. So we can give this one like literally the maximum value as that the degree is in the end. And then that's what it is, what you pass here, the maximum degree that it can contain. I'm not sure that all the coefficients are filled with 0 though. Let's have another look. Yeah, I don't think, I'm not sure, but I'm actually not sure at all. I mean, I think you just pass a length here, so it makes, yeah. Normally it would make a vector with default constructed objects, and then when it is built in, it might make it to 0, but I'm not even sure. Which is highly annoying. But well, I think yeah, I expect it to initialize everything with 0. So let's assume that it does that, and then if it doesn't, we'll probably find out. So this would be a completely 0 polynomial now, and I can initialize this one as PNM1. Yeah, so this used to be P1, but we start with n equals 2, and then we want these things to be initialized as the P of n minus 1, which then means P1. So we initialize Pn minus 1 as P1 initially. And then of course the same kind of thing here. Because this is Pn minus 2. No, I can't use a move because I really want to return one that is constructed with n coefficients. Well, n plus 1 coefficient. N coefficients? Wait a minute. I didn't see a plus 1 there. Number of coefficients. Oh, it's not a degree. It's a number of coefficients, which is... Yeah, the degree is one less. Yeah, oopsie. So n here is the degree. So the number of coefficients is one larger. Oh yeah, that is so. This is not correct then. What I'm doing now. No, I want to return this at all times. By the way, this is a return by value. So I said it many times, but the C++ has something like what is the word? Oh my god, it's a blackout again. Copy elation, I think that's the word. So it's returning by value, but nothing is being copied. What happens is that the caller is allocating this on the stack. So by the time we enter the function, it already exists, so we don't have to construct it. Which sounds weird if it doesn't have a default constructor. So yeah, I just allocate space on the stack, and we still have to initialize it by calling the constructor, I suppose, here. But that's why I definitely want to have this at the top always, because this and that just takes the same space. So I want to have them together, and then at the end of the function we just do a single return for it was called Pn. And then I can make my special cases like this. sorry, I just simply assign it to Pn. And that is then not a move, because yeah, we made it 1 degree less, which is then maybe not the smartest thing to do. And now we have to copy everything here. Create the whole thing, override it again. Let me see how, do I even have an, I don't think I have an assignment here for that. Is that a kind of stupid? What happens if you assign the two vectors to each other? Yeah, it just ooh. So the assignment operator is not defined by me, so the compiler generates it, which means it's just going to assign member by member. So it's going to assign this member with the vector of the other polynomial, and the size of that polynomial then determines the size of this one. And that's what I didn't want. I wanted the size to be fixed. So we can't do this. We really have to use the same size for all the polynomials every time we make one. And then now the size is the same, I might as well just return it. And then I move it. Because for a vector, moving is really faster than copying everything. I mean, the vector has internally just a pointer to the allocated array. So if you move it, you just make a copy of a single pointer, which is faster. So we're going to return. No, I need P0, so that was this one. I'll type return P0 here. Okay, so I do not need to calculate this in the case of n equals 0. And we don't need to do this one. I wanted to do it at the top, but now I'm returning this anyway, so forget it. I mean, I think the compiler is smart enough anyway. It's my preference to put it at the top, but I think now it's going to use the stack space for that is already allocated at the moment we enter for the return value is probably being used for this one. Yeah, I'm just not going to worry about it. So I'm not really interested in speed for this case. Or maybe I should still put it at the top. I think I'm going to put it at the top. This is the result. Put it at the top. And then we do this one. Now it's kind of silly to do that. And if I do that, I have to return Pn. I fucked something up. Okay, now these two are already done now, because we have them defined here. Pn minus 2 and Pn minus 1. They're already defined and assigned with the correct values. And this is already 0. Well, a 0 polynomial now. So then we get this loop. Also not super interested anymore in the Legendre comparison because everything worked, right? We have the correct definitions now. There we are. Okay. Now this is working because I can just assign the whole polynomial to another polynomial. And they all have the same number of coefficients. But after this line, I'm not using the value of PNM1 anymore. I wonder if I'm allowed to assign to a moved something, probably. Just in my head is that if you move something, then the only thing you're allowed to do with it is destruct it. Maybe ChatGPT knows, although whatever it says, you can never really believe it. Let's ask it. Normally I would ask this on IRC, but then you have to wait 2 minutes. No, yeah, well, let's believe it. It actually has a reference. Oh, Microsoft. Okay, I'm not going to do it. Just kidding. So, instead of copying stuff, let's use move assignment again, which is a lot cheaper. So that means that after this, then Pn is kind of in the undefined state. So hopefully we'll do nothing else but assigning to it, and that's what we do here. That's completely plain assignment. So it's not even necessary that it initially is 0 here. So I just won't make that remark. Okay, now math polynomial does not work with NP real, it works with doubles. So let's start with replacing all the NP reals with doubles. Multi-precision real, double. And yeah, n is an integer, alpha is should be double now too. So we just have our A and B and C and everything. It's just a function of n and alpha and beta. Calculate, calculate, calculate. And then I want to assign this, which is A1 times T, we don't have t anymore, right? I want to, that is now the variable of the polynomial. Let's first split this up then as a1 times Pn times t, and that now I hope or thought, or I'll probably just have to add it because I don't think I saw it, but you should be able to multiply a polynomial with some double. That just means that every coefficient of the polynomial is multiplied with that. Same thing here. So yeah, let's add support for that. Oops. I think I have a lot more support for that kind of stuff in the cubic polynomial and the quadratic one. This one is almost empty. Silly. I have a derivative and a long division, that's it. Stupid. And get roots. Yeah, it's not enough. Let's copy some stuff from cubic polynomial. Cube. What? Also not. What? Also just long division and get roots and access to the coefficients. Okay, we have an inflection point and a second derivative. Shoot. I'm sure I was able to do that. Quadratic. Yeah, here we are. These operators, they should be available in the other ones as well. Okay, let's just copy them, because I think that's almost the same. So this is subtracting another polynomial, adding another polynomial, just adding two polynomials, subtracting two polynomials, multiplying with a double and multiplying from the left with the double. And that's it. Yeah, well, it should be sufficient. So copy that and then go to the cubic to add it there as well. Polynomial. I don't know where to put it. Let's put it below these. What were the other ones? I don't know anymore. Let's see, so the coefficients here is a fixed array, size, sorry, an array with a fixed size. But yeah, that just means that this is a constant. It's going to compile as a literal. For the rest, nothing changes. just coefficients. That is expressed in the above one, so it's definitely not changing. And again, so no, nothing has to be changed. Oh wait, no, but that's a long division. Yeah, so nothing has to be changed. So I can copy it again and then paste it also in the normal polynomial. So let's put that here as well. No, yeah, I don't know. Yeah, where shall I put it? Let's put it here. Random place, 43 lines. And then substitute cubic polynomial with just polynomial. Now, yeah, and also this thing has coefficients. This time it's a vector, but if we just use size anyway, so it worked. This works. Good. So now we can multiply this double with the polynomial, and that returns another polynomial. Same here, same there, and we can also add and subtract polynomials. The only thing that still doesn't work is this times t, because we don't have a t. But we have a t if I define it as a polynomial. So I can leave it like this. Hell, I could leave it like it was. I think just multiply with Pn m1 afterwards, just multiplying two polynomials. Yeah, that works. We have that. Multiplying two polynomials sounds pretty involved. And I implemented it. I'm going to do that. So it was like this. And I think it's totally silly and the way these things are numbered. So maybe I should change that. But we're going to need a new t. And I really hesitate to make that one a degree n as well. Polynomial t. So that's just single degree. And then we have t1 equals 1. Now I think this should work. Let's first check if it compiles. I want to have a look though at the implementation of multiplying two polynomials. So this is a double times a polynomial and then plus plus a double. Didn't see that one. So maybe you have to add that too. I just want this to work, period. And then it becomes a polynomial anyway. So this was already polynomial, so polynomial plus double must work, and then we have polynomial times polynomial. So there's a single multiplication here between two polynomials. By the way, this calculation results in a temporary. So if you assign a temporary to something, then it's used as an R value. So that thing is then moved. This is a move assignment as well. And no need for the standard move. Right. So let's have a look at the polynomial multiplication, which I just copied. Yeah, it doesn't exist. Okay. I'll have to add it then. Plus, I want to be able to add a double. It might work if you can no, you can't. If you could construct a polynomial from a double, then that would work automatically. So you have to duplicate all of this. And then make this a double. Now, this would theoretically still work. I just implement this operator in terms of that one. And why the hell is the order like that? Here the minus first and then here the plus first. I'm gonna swap that. Doesn't seem very logical. Still need to fix this one. So now we just subtract a constant. So yeah, only the constant coefficient must be decreased. And then here only the constant must be increased. Good. Yeah, I want to multiply two polynomials now. Do I even have? I'm not really wanting to do that, do I? The problem with that is then that the degree can become arbitrarily large. While I want to keep my degree constant. It's a bit tricky. Let's not do it. Let's not do that. I'm just going to not multiply with a polynomial, so we don't have a t here. Can't multiply with it anyway. So we have to manually multiply a p and m with t. Yeah, I think that's correct. Except this one. What is the largest value of I? So this thing has a degree of n min m, n minus m, which means that, I mean, the coefficient here is that degree. So I runs up till n, including n minus 1. I said n minus m, but it's n minus 1. And that means that this is just n. But Pn can have any value. Wait a minute, if I move that thing, it doesn't even have a value. It doesn't have a vector anymore. Yeah. Let's make a copy here. To at least preserve the vector of coefficients inside Pn. So this one is moved, so it doesn't. Then it has a vector inside of it that it can only be destructed or assigned, and then we assign it. So now we have a vector back, which yeah, is just equal to the vector in Pn. But then Pn has arbitrary values. And I still just want to assign it. I could move it here and then recreate the vector. Because you have to set everything that you don't assign here to 0, which is kind of annoying. I'm gonna move it. But that means, you know, after moving it, we're not allowed to do this assignment here. We first have to assign to Pn as an object. So we begin with assigning Pn a new polynomial. Constructed with n plus 1. So then hopefully now it is has a vector of size n plus 1 that is filled with all zeros. And then we just override the ones that are should be non-zero. I think now it's kind of should work-ish. Hello, Mark Post. So you're taking care of my chat. Yeah, it's not much chat, so no matching constructor for initialization of math polynomial. Oh, that again. Slightly annoying. And then theoretically I should even add that it is inside this function, of course. But it's a standalone function. So, sorry, a standalone file. So I don't think it's very hard to find back if this is the only one called Pn. If I will ever use it at all, I'm just giving it the name of the variable. Pn. Thought I renamed it. Pn was more logical. God, let's replace Pn with Pn. And really, I should do something like that for these things as well, because it's just a silly name. But hello, Matthias. Matthiesen. The unpronounceable, the most names here. 5 billion people trying to get unique names on YouTube. And they still didn't figure out that you should work with I can't find the word anymore, of course. Display names is one phrase. When I worked on IRC, I did think of something, but I could never implement it because people were against it, or I don't know. The protocol changes were such that you need client changes. The client coders didn't want to cooperate, so I was working on the server. And the idea is pretty simple. You would just state how you want to be seen. So you have the IRC is a big chat thing with 10,000 channels, but you only join a few channels. And then if you want to be John and you join a channel where there is no John, then you are John on that channel. I didn't see the problem with that. And if you join a channel where there is already a John, then you will be named I don't know, John 1, something like that. And you will know that you are now visible as John 1. And if you don't like that, then you can choose another display name. Oh yeah, there were people also against it, I think. They were like, yeah, but you need to be recognized by your nick. But it's just bullshit what they thought. I mean, you can change your nick to whatever you want. So if someone enters IRC while I'm not there and they take the nick Carlo Wood, then other people might think he's Carlo Wood? No. Well, actually they would. But you can log in. And then you can see that that person is not logged in under the protected nickname. But okay, then I have a unique Carlo Woods, my unique nick. Unique in the sense that it is network-wide protected with that login, which is, I think, yeah, not very sensible. No, I don't know how to. I mean, I never tried it. I don't even game. Yeah, don't know. We are finally at the moment again, since 1 or 2 hours, that I'm gonna run this thing. And it looks exactly the same, because we don't even use the function anymore. I'm still not using the function. Hey, it compiled. That was the big thing. It does compile. And now we're going to use it. So now we have 2 Jacobi functions. One that is evaluating it at a given t. And another one that returns the polynomial, the actual polynomial. So now I want to test if we use this one, if it still looks the same. That would mean then that this function works. So I'm going to use this instead of the other one. Okay, let me think. How does that work? I think I can just create the polynomial here by passing these arguments, and then we get back Pn basically. Which is now polynomial, and then we grab that by reference, of course, and then we use it. Just passing t. And this thing there returns a double. Drum ruffle. I've been programming for 48 years. It compiled, yes. And we can conclude that it's not working at all. Everything is 0. Yeah, I started when I was 12, and now I'm 60, so that's 48 years. But I didn't start in C++. I don't think it even existed yet. I've been coding in C++ for 30 plus years, which is still a lot. And once I started in C++, I never looked back. I've only been coding in C++. Well, it's a matter of staying alive along. Well, I did C for a long time. Also a long time. And then I started coding in C++, and I literally was, oh my god, this is how I think. It just, C++ matched so much better how I liked to code. I guess I was already trying to be object oriented and stuff like that. it's just way, way, way better in every sense. No, you will never ever see me code in C anymore. Now we have to figure out why all my polynomials are 0. How about, and this is now 0, 0, 1, huh? Not 0, 0. How about you just run it in a debugger? Step through the program. Okay, we're working with beta is 1. And I want to step through it with the debugger for n equals 2 and higher. Might as well start at 2. That's easier. And then I set breakpoint here, 492. All good C++ coders that I know, that I personally think of, oh, well, man, that's a good coder. He knows his stuff. They all tell me they started at 12. But I started coding at 12, but not in C++. I started like I was almost 30. So it's not too late. But it might matter that you have to be pretty young if you start coding. It's still, you know, I started, for example, well, how do you put it without sounding super arrogant? But I have a special set of brains. It still sounds almost arrogant, but okay. So I was thinking that at some point I can do everything very good. I'm going to play chess, and then I have something to show for the way that I think. But I started chess at 18, and I've never become good at chess. It's just impossible. If you want to be significantly stronger than what I reached, you absolutely have to begin young. And I think the same holds for coding. I have been seriously coding from a very young age, not just, you know, a different language and it didn't matter. No, I wrote really serious things, even though I wrote it in BASIC. And that helped shape the neural pathways in my brain still, even though it wasn't in C++, I think. Breakpoints is set, run. We start with n is 2. Step n. Okay, first question was, does it initialize everything with 0? Probably. It even ended like 0. That's oh yeah, n is 2. So n is 2, so we make a 2-degree polynomial, which means we have 3 coefficients, and they are all set to 0. Very good. And then we do make these two. Maybe I made a mistake here. Probably did, yeah. I probably made a mistake here. Well, it's not 0. No, I did not make a mistake here, because those two are good. They are good. Okay, so we can print this one, this one is P0, that it is literally 1. And yeah, so this is 1 plus 0 times t plus 0 times t squared. So it's just a constant 1, which is correct. And then this one was a straight line. No, it is definitely linear. And if you fill in t is minus 1, this should be minus 1. Sorry. Did it be minus 1? Was it minus 2? Well, it was minus 2, I think. Yeah, it was minus 2. Yeah, definitely 2. So there was 1, and then the next one is minus 2. Starts at minus 2. And the next one starts at plus 3, and then minus 4, plus 5, minus 6. So yes, if you fill in t equals minus 1, you get minus a half plus 1.5 times minus 1 is minus 2. And if you fill in t equals 1, then you get 1.5 minus a half is 1. So this is correct. And then we calculate this. I didn't even change this code, right? It's just still the same code which worked. A is n plus alpha, and then so on and so on, and didn't change that, or that, or that, or that, or that, or that, or that. And that means that now we should be able to create a polynomial. And this one is going to be b, like the comment says, so it should be a1 times be n minus 1 times t. So this one was that, and then a1 is that, 1 2/3. So we, after this loop, if this is true, we should end up with 0, and then the minus a half is shifted there, and then times 1.666, so the half of this is 0.833, and then that is minus 3 times that. So I'm just going to do the next. Two assignments. And now I can print it. And it is indeed 0, and indeed minus 0.8333, and then minus 3 times that is 2.5. Yeah. So far so good. And then my phone is getting sentient. Yeah. And then I add to that a 2 times p times n minus 1. Yeah, this has to go wrong now. Maybe, I don't know, just gonna skip. Operator, factor, result, right hand side, print, right hand side. The right hand side is minus, that's that thing, okay, whatever. And then we do next, result times is factor, so step, and then for all coefficients, multiply the coefficient with factor. Well, I wouldn't know why that would not do what I want. the buzzer goes off. That's our result that we're moving there. I just calculated Pn. And now we are at the end of the loop. And now we return Pn, which we just moved. That is not what you should be doing. So you have to return this now, because it was moved there. Okay, let's have a closer look at this function again. Now I know what is wrong. Now that's the whole, I mean, if this is the end of the loop, why waste CPU with assigning stuff here, which is 2 clock cycles, but okay. The point is that if you are just calculated this and we are at the end of the loop, then we should stop, shouldn't we? So I'd rather do this at the top of the loop. Not that we win anything with it, except that now if you leave the loop Pn is still intact. That helps. And it also means that instead of assigning to Pn minus 2, I should be assigning to Pn minus 1 now. And yeah, this one as well. So this should be now Pn minus 1. Which means that this is Pn minus 1. That's a P0 at that point. And this should be called Pn. And then we don't even have to do this anymore, just the loop test already does that. So I still need a Pn minus 2, but not here really. So just a variable, and then put it here. Yeah, if you return Pn, it has to exist. Just silly. Let's not do it like that. I'm just going to set the Pn 0 to 1 here. So I don't need this one anymore here. And then we can do that one here. Yeah, it works. Except for one thing. We lost our constant. The constant is gone. But then, and the 2 is gone. The two, both the two initial values are gone. Why? But then we get the 3 here. And then the 4 and the 5 and the 6. And minus 6 was indeed the last one. We can reason backwards, and there must be a minus 2, and then the constant is at 1. Yep. So almost, but not quite. That's really strange, because this is my constant. So I have Pn filled with zeros, and then if n equals 0, I set it the constant part of the polynomial to 1. And then we return that. But how is that not working? Oh. Imagine even getting... a worse memory, so you don't remember that. You put NR2 here. At some point, your memory, you get so old that your memory gets so bad that all you do is waste time. Yep, so it totally works. This is the constant one and at 1, and then you have one at a straight line from -2, and then from 3, and then from -4. And this is with symbolic polynomials. So stay around, because I'm not even going to bed now. This is getting exciting. These polynomials are said to be orthogonal. Stupid English people. Orthogonal. Is that, do I pronounce that correct? Which means that if you consider them to be infinite dimensional vectors. So let's say the horizontal axis here, every point is a coordinate, but an infinitesimal. Just pretend that every pixel is a coordinate. Then you have a very big dimensional vector. And if you take the dot product between two of those vectors, then they turn out to be have an angle of 90 degrees. So they are orthogonal, right? If anyone takes the nickname orthogonal, I'm gonna kill you. I'm just kidding. Okay, so how do we do that? Well, just like the dot product, you just multiply each coordinate and then you sum it all up. So that's equivalent with an integral, the integral of one polynomial times the other polynomial over the horizontal axis, which is like at every point you take both values and you multiply them, and then the integral is a big S, as you know. That's just the sum of all of that. And therefore, to verify if these functions are orthogonal. How do you pronounce it? Orthogonal. No. Orthogonal. Orthogonal. I pretend that it is funny. Okay. We can calculate. Oh shit! Then I do need to implement multiplying polynomials. Yeah. So for each two polynomials, we can multiply the two polynomials and then take the integral between -1 and 1, and that should be 0. Yes, and that's what I want to test. The only downside is that I still don't have the code to multiply two polynomials, but I'll just add it as well, I guess. Okay, so this draws it, doesn't remember it. We want to remember it, so I'm going to add an array. No, yeah, make it a vector, otherwise I have to add a default constructor. Hey, pretty function. Orthogonal. Orthogonal, niet gonal. Gonal. Why is the all between parentheses? It's confusing me. Orthogonal. Okay, explain the parentheses. Is that because I have to swallow it, or to almost not pronounce it, or something? emphasize. Oh, it is the emphasis even. So it is orthogonal. No, all. What is it? Null. Not. Is it all? Orthogonal. I don't believe that. I'm pretty sure the emphasis is at the though. Orthogonal. Isn't it? Is it orthogonal? Orthogonal? I find it easier to pronounce my medicines. It's long, difficult Latin names. I can ask ChatGPT, you know. I can put it on voice on my phone and then ask it to pronounce it. 6, right? Okay, so we call these J01 polynomials. As long as you have a name, and then J01 pushback. It's making a copy again, but there's nothing you can do about it. Let's be the default by reference, but we copy n. Or should n be first? There was something there. So I'm just again, I just can access my vector now, and then add n. Let's see if it compiles and runs still before we take the next step. Yeah, I was thinking about arrays. Yeah, that works. Okay, so now I want to run over every pair. So let's say we just run over n. Yeah, still capital N. I have something against capital variables. I don't think it makes any sense to do them both ways, so we'll just start at n1 plus 1. Which then means that we might as well not go further than 5 here. So now n1, n2 is larger than n1, but n1 and n2 are different, which is the main thing. And then for each of these we want to calculate a polynomial that is a product between them. So let's call it product, whatever. Product is this polynomial times the other polynomial. And then then the next step is to integrate that, but let's begin with being able to multiply two polynomials, because you can't at the moment. Okay, so yeah. Smoothing function. Wait a minute, I want to go here. Yay, I have a CXX file. Okay, so I'll just add a multiplication now. That is a free function to make it a friend if at all necessary. Something returning a polynomial from the left hand side and the right hand side. Hopefully this friend puts it in the current namespace. I'm not even sure. But usually I like to declare stuff before the class and then say that it is a friend, because otherwise my experience is that if you just say friend and then declare for the first time something, that it's kind of a gamble which namespace it ends up in. So I guess I just don't understand how that works. We'll try it. Okay, so let's add that one at the top. Or maybe I should do it the same as with the others that I'm just implementing. Yeah, maybe that's better. I'll just implement this like that. So we just have the right hand side. What? The right hand side? No, I want the left hand side. And then multiply that with a multiply becomes the right hand side. And then add a polynomial, well, that operator. So that is on the right hand side because of this. I'm afraid I keep doing that. Yeah, someone else already pointed that out. Yeah, no, you're right, I did. Keep saying that wrong. It is a polynomial, and I just inserted an extra n. Yeah, but I write it correctly. I just say it wrong. Polynomial. Is that correct? Polynomial. Okay, let's figure out the degree. I don't want to just blow up the degree. So maybe I want to figure out what the real degree is of both. Let's see, I have a constructor that takes an int. No, yes. Number of coefficients. Control N F8. What do I have in my mouse buffer? That. And that was an int. Is this correct? So if the degree is, say, 1, and the degree of the other one is also 1, then we have two linear polynomials. So that becomes a quadratic. And I'm doing it wrong, because now I get 3 here. No, the degree, sorry, the number of coefficients is 1 larger than the degree. And the result degree is, of course, the same, is the additions of the degree of the two polynomials that you multiply. And then plus 1 for the extra coefficient there. The constant, whatever. I'm gonna even put it up front. It's even more logical. You can see any logic in it. This, however, oh yeah, now we can define the result. No. That is this. You can resize the thing already. So we are ready for. So I'm going to resize it to coefficients is vector of doubles. You can just call resize on it. Yeah, with the number of coefficients, of course. However, I don't want to decrease the size. If the current object is a certain size, then don't touch it. So it must be the maximum of that and what it was, what it currently is. I enjoy that a lot. Mathematics is at least as interesting as coding. So to combine it is the best thing of both worlds. Now I have to write the actual degree. Does not exist yet. Into actual degree const. Let's begin optimistically with the size of the coefficients -1. And then we return that, but while something and minus degree. And that means that we cannot go lower than the degree of 0. Can we have a degree of 0? Yeah, of course. Degree 0 means that it is just a constant. You cannot go lower. So while degree is larger than 0, we can decrement it. And might not even be necessary. I'm not sure yet. So the size of this thing is the degree plus 1, the highest degree plus 1. This is the highest index that you can use. So we look at the highest index, and if that equals 0, then the actual degree is 1 less than what we thought it was. And then we try that again and again and again until we find a non-zero coefficient, and then we don't decrease it and return it. For example, if the highest coefficient is immediately non-zero, then we don't decrement it at all, and then the degree is just the expected degree, the maximum degree that fits in it. Is this necessary? Yeah, I think so, because if, let's say, the whole polynomial is just zero, so all coefficients are zero, then we'll end up with degree 0, and then we test this, and it is still 0, and then degree becomes -1. And then the next loop we read undefined memory, out of bounds in the vector. And I don't want to ever return -1, so this looks like the correct function. Now we have to still multiply those polynomials. Yeah, it is the general formula for multiplying polynomials. I'm still saying it wrong. Polynomials is something with okay, this is just, it's not funny anymore. Why can't I just not find that word? So, it starts to be like every 5 minutes that I don't know a word. Binomial is it the word? Yeah, something with a binomial, right? And memory is one thing, but it's of course also completely stupid that I don't know how to do this from my head immediately. Like, boring. Binomial, yeah. N over M. So, I'll have to look it up. Maybe it's just stupid, I think. Maybe it's actually also a matter of memory. Of course, I've seen polynomials being multiplied before. I have seen those formulas before, and I can just totally not remember it. That's the problem here. It is for, I want a general formula. This is one of the most annoying things ever, that if you look something up, then they give you one example. Look at this YouTube here. You want to learn how to multiply polynomials. Oh, I'm not interested in just multiplying with a polynomial with a +5. I'm interested in general multiplying polynomials. Why on earth fill in numbers here? Just do +a instead of +5. And because everyone is doing it with these stupid numeric examples. Now I have to click and click and click until I finally find one that is in general. Oh, why would you even want to multiply to it? It's even better to talk about. Ah, finally, there's one that does it with symbols. But yeah, still not really general enough. And then we get examples again. There we have it. Finally. As well. So if this is one polynomial, that's the other, then the product is this. Is it now really so hard to write this? This is simple. This explains every product. And then all the other people, they need pages and pages of little random integer numbers to explain between really fat quotes how to do it. And then you stare at those formulas, and then basically you are required to recognize this formula from that example. Why would that be easier than just getting the formula? Yeah, and it is incredibly logical as well. That's why I said that I was stupid, that I just couldn't figure it out myself. It is really unbelievable. Okay, so you just have to run over, you just have to use two loops. Pretty convinced about that now, right? Yeah. Let's call it the left-hand side. It just doesn't work. This doesn't work. I'm gonna do it the other way. To make it a free function, we just multiply left and right hand side. Yeah, this was over. Exist. Okay. End up here again. Or yeah, that should be it, shouldn't it? Okay, now we can multiply two polynomials. So this now should to compile. Damn it. Pretty function if you're still there, but that's just not true. It's not easier. It is not simple. Simple is the general formula where you have everything at once. Then you see the structure. Then you don't have to figure it out yourself. It compiles, right? Yeah. So now we want to integrate it. So definite, how do you call that? Definite integral? indefinite integral. No, you have to write the integrate function. I do have the opposite. You have the derivative. Oh, I did that wrong all the time. The thing has a symbol name. Yeah. You see, I'm really stupid. If you wanna know stupid, this is me being stupid. Of course it has a symbol name. If you want to be able to print the polynomial, then you want to print x, and x is squared, and x to the power of 3. Not the name of the function. Let alone the variable name that I used at a random place. Arg. Result, coefficient size +1. And then the same symbol name. Let me immediately fix that. Symbol name, symbol name, symbol name, symbol name. I did only do that here. Yeah. So here, yeah, we just picked a symbol of one of them, I suppose. It's the thing of friend. So we'll just take the symbol name. Of one of them. That the only one? Could be kidding me. Yeah, thought there's all the others in math polynomial. It's not even listed here. Nobody knows. Nobody knows. I was just here. The fuck? The diff. No, it's a smoothing function itself. Oh. So we call that thing T. I see a question. Sorry for this question, but I saw something somewhere in your code variable equals 0. Is that correct? Let's save. Good question. I had to think about that myself as well when I wrote that, but yes, it is safe. Floating point makes a very clear distinction between 0 or not 0. Especially when you divide by it. So if you say you have something that is not 0, 10 to the power minus 30, say, and you divide by it, that's the same as multiplying with 10 to the power 30. And that's all nice, except when the result doesn't fit in a double anymore in terms of the exponent. But the largest exponent is like 203, I think. So, yeah, by that time you need a long double, or you need a multi-precision rail or something, if you run into that kind of stuff. So I found out that if you say if you try to divide by, let's say you have 10 to the power 200, and you try to divide it by 10 to the power minus 200, yeah, you just get an exponent overflow, and the result of that is plus infinity. So if it doesn't fit anymore, then it makes it plus infinity if the exponent is overflowing. Or if the exponent is underflowing, so you want to go under minus 203, then that makes it 0. That is plus or minus 0. Both equal to 0, by the way. So the reason I test it is because I assume that my exponent can store every exponent that I ever encounter, and I just want to make sure that I don't divide by 0. It compiles. Okay, so I was integrating. We have the results. And we have to do the inverse of this. That probably does a single loop, isn't it? See, I feel stupid again. How do you integrate? I'm really... One of these days I give up on programming. Maybe in 10 years, but it's definitely going to happen before I die. It's a sad thing. So, okay. So let's say I have C0 plus C1 times T plus C2 times T squared. Integrate this. Then we get to C2 times T to the power 3 with 1/3 in front of it. And this becomes T squared, so there's a half in front of it, and this becomes C0 times T. That would be the indefinite integral. Can add some constant, but I'm not going to do that. So, yep, easy peasy. And for this is fairly. This is the new C3. I'll just have to run backwards. Pretty sure that we'll just have to go the other way. this runs over all coefficients. This runs over all coefficients of the current object, polynomial. And then we are going to assign that. I'm assigning it to a completely new polynomial, so I don't have to run backwards. Let's just run the normal direction. So then the result plus that is that divided by I. It's not going to work for I is 0. Divided by I plus 1. Obviously. Yep. Yep. No, that's integrand. Now I want to turn it into the definite integral, which is simply a double. Where we evaluate that thing at 1.0 and then subtract, evaluate it at minus 1.0. Yeah, I want an integral sign that is one character. Don't have that. I will find it. I will find you. Integral. The integral of I'm not feeling secure at all about this outcome. It feels almost like gambling. It should be printing 0. Like 20 times. What will I do that? Shit. Totally not 0. Yeah, to be honest, you can even see that it is not 0. You take the dot product between this one, which is just 1, and any of the others, and they would be orthogonal, then that means that the area under the green curve, for example, this area here plus this area here must be equal to the area here. Totally not the case. This is clearly way, way, way larger. Oh, wait a minute. I'm integrating the wrong stuff. It is orthogonal under the weight function. So I have to multiply it with the weight function as well. Maybe even the square of that. So I have to multiply both with the weight function. Yes. Now the weight function is 1 in the case that beta is 0. So the Legendre polynomials, which you get if we use so yeah, the variable now is called 0, 1. I'm going to make it 0, 0. And then we have the Legendre polynomials, which have a weight of 1. Which means that then I do calculate the correct integral here already. That should be definitely 0. Yep. Oh, and it is. Beautiful. Everything is 0. I'm not looking at this 10 to the power minus 16 is also 0. And then even better, if we make it 1, then it should also be 0 if you multiply this thing with the corresponding weight function. And now the weight function is also polynomial, so I have to probably make a polynomial first, otherwise I can't integrate it. So let's make a polynomial called W, which has a degree of 1. Sorry, the 2 coefficients. Let's see, what I want is something like, okay, I get the weight function is defined as 1 minus x to the power alpha times 1 plus x to the times beta. So since we pick 0, 1, well, I could pause it here. Alpha is 0, this is 1, and beta is 1, so this is just 1 plus x. And the reason we pick those values is then that every polynomial is 0 for x equals minus 1. That is after multiplying with the weight. Okay, so this is 1, that's the constant, and this is also 1. That is the coefficient of the x. Let's talk about t here as well, because it's still on the interval of -1 to 1. And then having that, I can multiply each of these Jacobi polynomials with w, both of them, and now we should have an integral. Well, the definite integral is then the yeah, how do you call it? I would call it the dot product between the two. But that should be 0 now. Please be 0. Then I can go to bed and have a good night. Sleep deep and well, smiling the whole night. What was the problem here? Oh, comma w debug only t semicolon top make compiled run all zeros and end of stream. No, not really. I'm going to play one game of chess then. Yep, it does not work. Well, almost, but it doesn't work. Shit. There's a lot of zeros though, but this one is not 0. This one is not 0. This one's not 0. This one's not 0. This one's not 0. Well, that should not be happening. The T function. Hey man, help me. Why is this not 0? There are so many are 0. But this for the most simple one. So that means that this green one multiplied, maybe I should plot the thing, let's plot the thing that is multiplied with the weight. So I want to now multiply, let's move this up. What am I doing wrong? So the ones that are not 0 is this one, 0, 1, and this one, 1, 2, and that one, 2, 3, and 3, 4, and 4, 5. I do see a pattern there. 0, 1. So this one is 1 higher than that one. That is 0, that is 0, that is 0. That is 0. And then the 1, 2, not. And then again 0, 0, 0, not 0. 0, 0, not 0. 0, not 0. So every time you take, if the distance is 1, then it's not 0. Okay. Let's ask ChatGPT for suggestions. I'm gonna start a new chat. Well, that's interesting. It just multiplies it once with W. Well, let's try it first to know if this is indeed the answer. I'll just put a W at the end. Just like ChatGPT. Look, Mom, I'll do it like ChatGPT. No, that was it. Now it's all zeros. Yeah, that's not what I expected. Yeah, no. It wants me to make my own orthogonal basis. I mean, I can think of a solution myself here. You just take the square root of W. I was just wondering, you know, if I'm missing something. Like, maybe I should use these Jacobi polynomials as my basis anyway, and then use that weight. Yeah, no, I don't know. I have to go to bed, so let's stop with the mathematics. I'm gonna play a game of chess and then actually go to bed. I'll think about this tomorrow. Play. Oh, come online, I mean. Use online. Caligula. Caligarius. 7 seconds. Okay, goodbye. I don't want you to play anymore. Oh, you're boarding too many games. Yeah, okay. Go ahead. Well, I'm mostly losing when I play chess after a stream. But I don't feel tired. It's just that, you know, the clock says it's this late and I should just... I shouldn't stay up till 5 a.m. Oh, is that possible? I don't think this is possible. Let's see. So I take here, he takes back, I push this pawn. I threaten to win the queen. So he can't take, he can't push. Queen or king move. Well, this bishop can be played. Then I play my bishop anyway, so then the queen moves. Yeah, I would have to take. Then the queen still defends this pawn. I was hoping to win this pawn then. It's just not happening. I could also push this pawn first with the threat to win the queen or win a piece, but he's gonna push probably. And then if I take here, he could not give away his queen, but just take here. Oh, and then I win a pawn, because I defend the knight as well. Okay, I think this works. Costed 2 minutes. Yeah, that just gives away a piece, right? That's, I just fell for my trap, basically. He had no clue what I was doing. What? Even now? Even now? Why am I thinking this deep? Tja. The rating is all pretty low, of course. Let's try one more then. E4. Oh, new opening. Every opening is the same. sucks to be him. Or her. Or it. Resigned. It was too depressing. Well, under those circumstances, I just have to play another one, right? Keep winning. It's not good. If I play online, I should lose. D4, yeah, okay, yeah, here's the losing game coming. Yeah, I guess we just do this, and then we do this maybe, or first I play, of course, that. Because I read a book about a Caro-Kann. No, not a book, actually. A YouTube. Nobody knows why I would not take here. There's a check coming, maybe. So we take, check. It's not a double attack. Do everything. Just put my pawn in the center. That wouldn't be too bad either. Yeah, I'm gonna take like that actually. Maybe that was not the best move. Now I think about it, probably not the best move. And the knight is coming here with this horrible threat here. Basically dead. He thinks the pawn is poisoned. Now, why would I do that? Well, to play my rook, but should have played this pawn. Use that bishop sooner. Bad rook. Bad knight, I mean. Plus it was attacked. Let's turn it from an edge knight into a fork knight. This knight is hungry, but eats with a fork. You think this is actually doing it, helping my development with the bishop that was moved 20 times already. I should probably castle. Let's castle. Threatening to win my pawn back, so he was forced to do that. Yeah, I have to use the rook. I know, I give away this square again. The whole idea of this rook was to stop the knight from coming here. And now I blocking my rook. And the rest. Stupid. Dang. That is attacked. And that one is attacked. I'm losing another pawn? Could be kidding me. Looks like it. Can take here. Can take there. Theoretically. Then I have to take here, obviously. Unbelievable. Still have this, but it doesn't make me very happy. Whoa. I like that. Yeah, I could text it back. Well, if I take it, I'm mate into. So if I move my rook, then I lose the bishop. Could go here though. Then I lose this pawn. No, I don't. Might not be that bad. I can give check and then take the bishop. So there, turn, check, I go here, and then take the bishop, I take that, and then he can take my pawn. It's not good. Just do this. Oh no, the pawn is still shit attacked. Fuck. It's going anyway, the bloody pawn is going anyway. Actually I should have done that immediately. Thank God he didn't take the pawn. I know he can go, but yeah, then I win the pawn. I can do this. Now let's first develop this thing. I'll get rid of that thing because I don't have any fucking time left. That is not a bad move. Yep. Yep. I moved because I didn't have time, but might as well give up, of course. Okay, I lost. Now I can go to bed. Good night.